Thank you so much, Lisa. And I wanted to find out more of how you gather information about young stars and planetary systems.
So I use spectroscopy to do most of my observing and my research. And I'm interested in particularly how young binary stars form, and also in the potential for planet formation around young binaries, and also how planets form, because you can use spectroscopy to study things that you can't figure out any other way. Now, what spectroscopy is a little bit complicated, but if you actually think about a rainbow, or the light you get when you put a piece of glass, like a prism or crystal, in the sunbeam, you'll find that you get all the rainbow breaks, the white light breaks up into these different colors: purple, red, orange, yellow. So you'll see this spectrum of colors. That is a spectrum. But with a prism or a piece of crystal, that's a very crude spectrum. So what I do is I break out light into very fine degrees, so I can actually see in a spectrum that I collect with a telescope like the Discovery Channel telescope, and I can actually see what elements, what atoms are in the atmosphere of a star. And in particular, I look at young stars, and I look at some young stars that probably have planets forming around them, and I can actually use these spectra. And it's kind of like a fingerprint, like these different atoms and molecules that are inside or around the star, in the atmosphere, in the gaseous atmosphere of the star. Those different materials are absorbing light at very specific wavelengths. So I can actually see how that light is absorbed in the outer part of the star, and that tells me what the temperature of the star is and how fast the star is moving. And I can also say something about the composition and how poofy it is, if it's very dense or if the gas is poofier in the outside of the star. There's a huge amount of information that we can get from spectra.
And what type of an instrument do you use to gather to do your spectral analysis?
So the kinds of instruments that I have used through my whole career, including here at Lowell Observatory, are high-resolution infrared spectrographs. And those, when I say high resolution, it's what I said a little bit earlier, that it breaks the light down very finely into its component wavelengths. And at high resolution, you can actually get all these great measurements, the very precise radial velocities, precise temperatures, and it's incredibly powerful for studying not just the composition and the physical properties of the star, but also how it's moving. And what's cool about that is you can, with the infrared spectrograph, you can see through these big molecular clouds in the interstellar medium where the young stars are just forming. So you can actually see through some of the clouds, some of the dust and gas, and you can see these young stars, and you can see them moving as the newly formed planets actually orbit around them.
That's amazing. And I wanted to find out, what is the coolest thing you've been able to observe?
So that's a great question. The last 10, 12 years or so, my colleagues and I had a survey going for how to trying to identify the youngest planet outside of our own solar system. These are like baby planets, newly formed. And it took many, many years and literally dozens and dozens and dozens of spectra over and over of the same star to map out how the star was moving, because there was a giant planet orbiting it every 9 days. And the star is called Ci Tau, and the planet is called Ci Tau b. And even more exciting, just in the last month or so, we have submitted a second paper. After our discovery paper 3 years ago, we submitted a second paper using the same infrared spectroscopy. We've actually now detected the atmosphere of that planet directly.
Wow.
So that's been reviewed now and will be published very soon.
Well, that is very exciting. I am so glad that you were able to take time out of your busy schedule to share with our friends on Facebook all of the exciting research that you're doing here.